Hello everyone. In this tutorial, we will continue the previous problem and we will see how the delay is calculated in this problem. So, in last lecture, we saw the concept of uniqueness uh, and correlated with that with the .lib liberty file. So before beginning this tutorial, there are some facts to be understood. So as we saw in last lecture, that output transition for any combinational cell is function of input transition and output load. So as we discussed it last time only, for delay for combinational cell, it is also a function of input transition and output load. So output transition and delay depends on the same uh, factors. Talking about flip-flops, so clock to Q delay is the means clock to Q delay, that is the delay for the flip-flop, or the transition is function of input clock transition, that is the clock transition at CK pin and load seen by the Q pin. And it is important to note that this is independent of transition in D pin. So it doesn't depend upon the transition on D pin. This is important point over here. So now the setup or hold time for a flip-flop is a function of clock slew and data transition. So basically, which arc is responsible for setup and hold time? That is clock to D arc is responsible. So these are also calculated with the help of the lookup table, which is a 2D table and is a function of input clock slew and data transition. So let's try to see that in our example. Yeah. So here in this example, we have the timing section. The related pin is clock and timing type is hold rising. So it will here it is not given, but it is in the form of a 2D table like we saw in case of transition. Uh, so it will depend upon let's say 0.1, 0.2, something like that, and something like that over here in Y. So it is input clock clock slew, and this is slew at D pin. So this is not fixed, but this can be seen better from the complete library. So this is how the setup and hold time are decided. Similarly, for okay, so this is this yeah. So for over here we are having the setup for D falling and setup for D rising. So over here we can see that here in index 1 we have clock slew, index 2 we have D slew, and the corresponding values are present in this table. So this is how it is present in .lib. So now what we will do is we will calculate now the delay. We will focus on delay calculation. So let's start with the actual arrival time calculation. So let's start writing the equation. So for case one, when D is rising, when D is rising, so T buff 5 rise, which will the rise delay plus T clock to Q UFF 0, and it is also rise plus T NAND A, it is fall plus T and it is also fall. So this is case 1. Now when D is falling, how to write the equations? When D is falling, so T buff 5 is a rise delay. So I am not writing the equation for a net delay over here. So it can be written in the same manner. So then we have T clock to Q. It now this will be a fall for UFF0. Then T NAND A is a rise and T and is again a rise. So this is case 2. So this is one with the corresponding with D falling, D falling, Q falling. This is negative unit, rising, rising. So this is how the equations are written for two cases. Uh, Now calculation for required arrival time. So this is T of 5 rise plus T buff 6. This is we are doing for setup, and T buff 6 will be also rising. So this is rise delay. And then we have TCLK minus T setup. Okay. So that means that we have this capture edge. So the data, this this is TCLK and T setup. So data must be stable at this point, before this point. So this is how the required arrival time and actual arrival time are calculated. So now out of this case, which case will be reported by the tool? So now we know that setup slack is a required arrival time minus actual arrival time. So required arrival time is this one, which is fixed, and actual arrival time having two cases. So we take the worst case for setup because we need to consider the worst case for this. So the tool will calculate the delay for this when D is rising. The tool will calculate the delay in this second case, and it will pick up the most worst one, which will have the maximum delay out of two. So this we can write that actual arrival time should be maximum of case 1 and case 2. So the tool will report the setup slack, which is having actual arrival time, which is maximum of case 1 and case 2. So which one is having the more value will be taken as a setup slack. So now you can try for similar for hold calculation. So that's all for this lecture. Thank you.